You clicked because you heard about a tiny model that does what massive ones do. You are right to be skeptical. The industry has convinced you that building autonomous agents requires billion-parameter models that cost a fortune and run slowly. But there is a breakthrough that changes the entire economics of this technology. We are about to see how distilling a massive system into 26 million parameters proves that complex reasoning is not necessary for structured tasks, and how this shift ends the era of agentic bloat. For the last few years, the narrative has been simple. If you want an agent that can call tools, manage workflows, and handle complex logic, you need a large language model. The assumption was that the intelligence required to understand a tool schema and extract the correct arguments was a property of general reasoning. This meant you had to pay for the entire model's capacity just to route a single function call. The result was expensive, slow, and often unreliable. Developers found themselves paying for thousands of tokens just to ask a model which function to call, only to have it hallucinate a parameter or fail to return valid Json. This approach was fundamentally flawed because it treated tool calling as a general capability rather than a specialized subtask. The industry kept adding more parameters, hoping that more brainpower would solve the problem. But the math simply did not work. The inefficiency was baked into the architecture itself. Standard transformers rely heavily on multi-layer perceptrons, which typically consume 2/3 of all parameters in a model. These components are excellent for general reasoning, but they are overkill for the specific job of parsing a prompt and assembling a JSON object. They are like using a sledgehammer to thread a needle. Enter the Needle project from Cactus Compute. This team took the tool calling logic from the massive Gemini 3.1 model and distilled it into a model with only 26 million parameters. That is not a typo. It is a fraction of the size of the models currently dominating the market. By eliminating the heavy multi-layer perceptron layers, they created a hybrid encoder-decoder architecture optimized specifically for retrieval and JSON assembly. The result is a system that does not try to be smart about everything. It tries to be perfect at one thing, calling tools. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The performance numbers are where the real story lies. On consumer hardware, this tiny model delivers 6,000 tokens per second during the prefill phase. That is the speed at which it processes the initial request. During decoding, the phase where it generates the output, it maintains a rate of 1,200 tokens per second. These figures are not just fast, they are a magnitude of speed compared to competitors. When you compare this to Function Gemma 270M or Qwen 0.6b, the Needle model outperforms them significantly in single-shot function call benchmarks. It is not just faster, it is more accurate because it was trained specifically on the distribution of valid tool calls rather than general language modeling. This distinction is critical. Current agentic systems often fail because the model cannot adhere to strict JSON schemas under load. They hallucinate parameters or return malformed structures. Needle solves this by training on the exact syntax required for tool execution. The failure modes of previous systems often stemmed from the model trying to be conversational while trying to be precise. Needle decouples these needs. It does not care about the nuances of human conversation. It cares about extracting the correct tool name and arguments with near-zero hallucination rates. This shift signals the end of agentic bloat. We are moving away from the idea that you need a massive general-purpose model to handle every step of a workflow. Instead, we are seeing a move toward architectural decoupling. In this new paradigm, the 26 million parameter model handles the precise syntactic extraction of tool arguments. If semantic intent or complex reasoning is required, a larger model can handle that, but only when necessary. This creates a tiered system that drastically reduces token costs for high-frequency autonomous tasks. You are no longer paying for the intelligence of a generalist when you only need the precision of a specialist. The implications for production adoption are profound. Developers are now replacing expensive large language model routing layers with deterministic, ultra-low latency inference that runs locally on microcontrollers or mobile devices. This changes the unit economics of autonomous agents entirely. What was previously a cloud-only, expensive operation is now viable on-device. The barrier to entry for building complex workflows drops significantly because the cost per call becomes negligible. You can now run autonomous agents on hardware that was previously too weak to support them. However, we must be clear-eyed about the limitations. This is not a universal replacement for general-purpose intelligence. The Needle model lacks the conversational scope of larger models. It is a specialized tool, not a drop-in replacement for a chatbot. User reports indicate mixed results when handling ambiguous queries or complex multi-step tool selection that requires broad context. The model is sensitive to fine-tuning and performs best when the task is well-defined. It excels at the specific job it was distilled for, but it does not possess the general reasoning capabilities that make large models useful for open-ended problems. This brings us to the future of the field. The data suggests that the career pivot for data engineers and architects is not about selecting larger models for better reasoning. The future lies in designing specialized, distilled inference pipelines. We are moving toward systems where speed and cost per call are prioritized over general-purpose intelligence for structured tasks. The gap remains in how we combine Needle's speed with larger models for broader context. Current benchmarks do not fully resolve how to seamlessly integrate this specialized tool into a system that still needs to handle ambiguity. But the direction is clear. The era of assuming more parameters equals more capability is over. We have proven that the intelligence required for tool calling is a compressible subtask, and that compression unlocks a new tier of efficiency. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.